In this update, we will take a look at the current state of a project, new features and some bigger changes how the software works. The last months were mostly filled with software development, so not much has changed in terms of the hardware because, as you may know, many chips are out of stock for months right now. But of course there will be more improvements to the hardware later for better performance and availability, but at this point the firmware needed some attention. So I will go over the most important changes at this time. I won't go too deep into the programming details, but want to mention the biggest changes and features for potential developers and users who are looking to get into the project. Initially, the FFBoard firmware was made to be as modular as possible, with the option to later support multiple motor driver outputs at the same time for multi-axis force feedback setups. This is now finally possible, although it's still pretty experimental. To make this work, a lot of the code had to be changed and moved into independent axes, with some help from the great community. To actually support multi-axis force feedback, some settings had to be moved into different tabs in the configurator. The main tab in force feedback mode now controls main settings like analog and digital sources for the gamepad output, and common effect settings like overall gains and the constant force filter, which now also has a user selectable Q factor for better tuning. The Axis tab, or tabs depending on the amount of active axis, controls settings specific to a force feedback axis. This is, for example, a motor driver and a position source. This motor driver has an encoder integrated, but if I select the other axis, which I have also enabled, we don't have a motor driver selected, so we now have a selection for encoders. We can only select the local encoder and no encoder. And as a motor driver, this is the old F411 board, which does not support PWM anymore. So we can select TMC1 or 2. And TMC1 can't be selected because it's already selected for the other axis. So the settings we can change for the axis are, of course, the intensity. So we can turn it completely down or up very high, and then the effects are stronger. We can change the range of over which the wheel rotates. So for example, I can turn it down to actually 180, and now the wheel only has a movement range of 180 degrees, but let's put it back to 900. Then we have the effects ratio, which gives us the ratio between the effects and the end stop effect. So how much of the total selected power is actually used for the game effects and how much is reserved for the end stop. So if you have a very strong motor, you might want to turn it a little bit down so you can get a stronger end stop effect. And if you have a weaker motor, you might want to turn it up to 100%. Then the range is the same, but you won't feel the end stop anymore if another effect is also at 100% power. Then we have the idle spring. This is, of course, the spring effect, centering the wheel when no force feedback is actually active. You can turn it completely off or up very high if you want a strong effect. And this turns off when we actually start force feedback. So now force feedback is running. You can see it now. Force feedback is on. And there is no idle spring anymore. And when we close this window, force feedback is off and the idle spring is active again. Then we also have a very interesting setting that was requested a few times and other wheels also have. This is the independent damper. This is an always-on damper effect, which can prevent oscillations, for example. So we can now see the wheel is oscillating pretty heavily, but if we add the independent damper, then it doesn't oscillate anymore. This can be pretty helpful if you want a heavier wheel or have problems with oscillations. This depends, of course, on the motor and the overall mass. This motor has a very heavy rotor, so it tends to oscillate a little bit more, and it's a little bit slower also. There's also the damper effect as a game effect, and this is pretty much the same thing. Now the wheel feels very heavy, and if I turn it off, then it is very light again. Same thing with this one, but this doesn't turn off when we stop the force feedback. We can also invert the axis. You probably don't need that. I can show you how this looks. So when I turn the wheel to the left, the dot moves to the left. If I invert it, it just inverts the gamepad. It also inverts the force feedback effects, so it should be right again for most effects. But if you have a game sending constant force effects, then this would also invert the direction. So you should be very careful with toggling the axis inversion. And of course you can set the center position of the wheel. This will just change the center. It's the same thing like if you would push the button on the board, the switch. This also triggers a centering of the encoder. The common effects in the main force feedback tab, as I already said, we have scalars for the games effects, like the spring gain. When we enable a simple spring, we can just change the gain of this effect from nothing to normal force. This would be normally at full force. Then it can go up to the maximum torque which you have set for the motor. Same thing also for the damper, friction and inertia effects. So yeah, damper can turn this effect off or very strong. Same thing for friction and inertia. And another very important and probably also very helpful function is the constant force filter. I have already shown this before, but we now also have a user selectable Q factor. So when I, for example, enable the force spring PID and turn the filter completely off, you can hear that it's pretty loud because when I move the slider, there are a lot of spikes in the force. But when we set a lower frequency, it suddenly gets a lot quieter. And with the Q factor, you can also change how this filter behaves. So you can make it a very light low-pass filter or extremely aggressive and smooth out pretty much everything. But you have to be also a bit careful because a very aggressive low-pass filter can of course also add oscillations again. So you should tune this to taste however you like it and what works best for your setup. In terms of game-controlled force feedback effects, all the standard force feedback effects are now fully implemented. There's of course still some tuning to do, but overall they behave like they should according to the official physical interface documentation. Most importantly, we have the constant force effect. This is just very simple. The game sends a force and this is then scaled and output directly to the motor as quickly as possible. But of course there are also some onboard effects that are calculated by the firmware on the device, because you can't send the constant force effects with time-critical accuracy like you would need, for example, for a good damper effect or a very smooth spring. So this is where the conditional effects come in. Conditional effects are, for example, the spring, damper, inertia, and friction effects. The simplest one is the spring. The metric is just the position. So it will try to hold a certain position. Very simple. Conditional effects also each have coefficients and saturations and deadbands. Saturation is just what is the maximum force where this effect gets clipped. Coefficient is a scalar. For example, for the spring, it's how stiff the spring should be and how fast the force rises. And the deadband is for all the same. Inside the deadband, the effect is not active. So if I set a deadband here, spring effect is not active, but outside the deadband, it suddenly starts a spring effect. Same thing also for damper and frictions. We have shown this in a previous video already. So inside the deadband, it's not active. Outside the deadband, it's active. Also with an offset, where you can move the range where this effect is active. Periodic effects are less commonly used these days and are waves that can be played back by the game on demand. They can be changed by altering its frequency, intensity, phase, and offset. They also have a duration, so they stop automatically after a set time or can be set to infinite. And if they stop at a certain time, you can also use a simple envelope function to make the effect fade in and out slowly. Examples of these effects are square waves, sine waves, triangle, and sawtooth waves. Another feature that was often requested is the ability to save and restore settings at a later time. So to demonstrate this, we have here some settings. We can select Save Chip Config, and this will save it to a JSON file, which looks something like this. Here. It contains a set of addresses and its value. And if we restore it later, all the addresses present in this file will be restored again. So to show this, we will make a factory reset. Now we are in the basic class, nothing is set. To make it a bit clearer, I can change into force feedback wheel again. And now we see all the settings are set to their defaults. But we can now load the previously saved chip config. Nothing happens. It was just written to flash now. So we will reboot. And as you can see, all the settings we had set previously are present again. This way you can, for example, share a preset with a set of flash settings and share it with other users. Or after a firmware upgrade, you could, for example, restore your settings. It is recommended to do a full reset, because only the settings that are present in this file get overwritten. There are no checks yet. We will probably have to do this at a later time, but it is a way to get your settings stored in a file and restore it later. And to simplify the firmware upgrading, we had a DFU mode for some time now. But what is new is that you can now also use hex files, which are directly generated by the compiler and don't need any additional script to convert to DFU files. And we can now upload the firmware. And it's also a lot faster now than before. In the hex file, there is a hole in the address space so that the flash page containing all the settings is not actually touched when you flash it. So normally the settings should remain even after a firmware upgrade. But it is recommended that if there are any issues, that you do a full chip erase and set your settings manually later. To make further development easier, it was decided to use FreeRTOS and replace the old USB system with TinyUSB, which came a long way since the project was started and can now also support composite devices and has FreeRTOS integration as well. With a real-time operating system, we now can have concurrent tasks that can use delays without blocking the chip. This is very helpful for the TMC initialization routines, for example, which were also partially rewritten to now use the safer closed-loop current control mode for the encoder alignment and calibration sequences. Obviously, having parallel tasks opens another layer of complexity and requires the use of blocking structures for peripheral access like semaphores and mutexes. For that, a C++ library for FreeRTOS was included to make it as easy as possible to use, and additional abstraction layers for SPI and UART ports are being developed as well. Initially, the USB system was based on the ST's middleware examples with a custom composite device layer and some modifications to the ST code to have both the HID and CDC serial port run at the same time. There were quite a few things to modify and bugs to be fixed, making it pretty hard to understand and modify at a later time. TinyUSB, on the other hand, makes it surprisingly easy to create composite devices and has almost all functions and callbacks implemented in a similar way, making the switch pretty easy. Actually, you can define a USB device and change the descriptors, strings, and PIDs now with minimal code. As the device descriptors for the composite and standalone version of the CDC port are now the same, the name of the port also won't change anymore when switching between those modes. So you don't have to worry about changing the serial port anymore in the user interface when we will activate a different main class. Even MIDI is supported again with TinyUSB, though the SOF callback is not present anymore and the timing has to be done with the onboard timers instead. The start of frame callback was an easy way to get an accurate 1 kHz signal for calculating effects and correcting timings previously. Overall, TinyUSB has been very reliable and made USB development much easier. And of course, you will still get a fast 1 kHz update rate for effects and positions, which is the maximum possible with full-speed USB devices. One thing I have already shown in the last update was that we can send and receive CAN data. So, for example, if I send the CAN command, we will see, well, yeah, it transmits the data with ID 1 and value 5. Nothing special, but one thing we can do now also is that we have integration into CAN analysis software like SavvyCAN using the generalized vehicle reverse engineering tool protocol. So when I disconnect the user interface, I can use SavvyCAN, add a new device, select our COM port, and it will start detecting the device with one bus and the speed of 500 kilobits. And now I can try to build a frame. Pass 1, ID 1, length 1, data, well, let's say 0x10, and trigger, enable, and now it will send a CAN frame with ID 1 and data 0x10. Of course, this also works with receiving data or also with the fuzzing function. So let's stop this, enable fuzzing and start ID 1 and ID 10 and let it try all bits. And now it will wildly send data over the CAN bus. There's also a simple error management system now. When I disconnect the motor voltage, I do get a pop-up in the user interface telling me low motor voltage. The TMC will create this error when the motor voltage is below a certain value. And this is then passed to the error handler, and all error handler listener classes in the firmware will then receive the message that this error has occurred. One of these handlers is the error printer, which will print out the error message to the serial port, and the configurator will listen to this and show you this error. You can go to the error window also via help errors, and this is an error we can also clear. And as always, huge thanks to my community and Patreon supporters. And if you want to learn more about the project, check out the links in the description and join our Discord community for more updates.